Hi, good morning, everyone. Welcome and thank you so much for joining us. My name is Holly Bridgwater. I'm a geologist and the Principal for Industry Engagement at Unearthed. I'm also super passionate about the power of data science and innovation to solve the incredible challenges of our time, especially around how we access the resources and minerals we need for the 21st century. So I was really delighted to be invited to host this webinar discussing fleet space technologies, revolutionary mineral exploration technology, ExoSphere. Now, we have received a lot of great questions during the registration process for this event, and we will answer as many of those as we can at the end of the presentation. So I'm happy to introduce our speakers for today. So today on the call, we have Matt Peason, co-founder and chief operating officer at Fleet, and Darren Smith, geologist and senior enterprise account executive who manages the ExoSphere sales team. So welcome to both of you, and thank you so much for having me.
Thank you, Holly. Thanks for being with us.
Yeah, thank you.
Awesome. So let's get started. And Matt, before we kind of get into the details of how ExoSphere works, I think a question that I'd like to ask, that I'm sure many people may also be wondering, why is a space company working on revolutionizing mineral exploration?
Good question. Yeah. Well, I think the biggest thing at Fleet, we, in our hearts, we're explorers. And we're really inspired by the explorers throughout history, and thinking about the opening of new worlds, the Apollo missions, now the Artemis missions. So we're hugely excited about what's happening in the space industry at the moment. Obviously, being part of this, it's there are these new missions to the moon and Mars that we're trying to play a small part in. And I think the biggest thing for us really is philosophically, we were founded on the principle of opening new frontiers on Earth and beyond, and building a more prosperous and sustainable future for humanity. So we see a future where we have a clean, sustainable Earth, and we're out exploring the stars as just about the most exciting missions to be part of. And these missions, I mean, they make you super excited to get out of bed each day, and ExoSphere aligns perfectly with what we're hoping to accomplish at Fleet. I guess if we think about our path to get into mineral exploration on Earth was really looking at how we're going to do exploration on other worlds. And when you have to think really carefully about every kilogram that you're going to land on another planet, and how much that costs, you start thinking kind of radically differently about the way we're going to do it. We can't do exploration with a few people in a lunar buggy or anything like that. Like if something goes wrong, it's very difficult to retrieve equipment to do things like that. So we started thinking about how to make exploration scalable. Space really has this problem of a rover is a multi-billion-dollar project, and it's very slow. You've got this little thing that crawls around the ground. Very, very difficult to do large-scale exploration the way that NASA's been doing space exploration so far. So we started thinking outside the box, and first, that's how we first started imagining how satellite connectivity with wireless, easy to deploy, simple sensors could help us find new resources. And we realized that the technology that we were developing for the moon and Mars was not only great for that, but could make life better here on Earth. I guess the other thing that's going on, obviously, is that we're in this climate crisis, and we've got these big goals around reaching net zero. And so that this future that we dream of is really threatened by this crisis. So we've been trying to figure out how do we play a role there as well, and use revolutionary space technology to help. And the truth is that it's a hard truth, but we just can't reach net zero emissions targets without a huge increase in critical minerals. We need a 6-fold increase. I think the IMF has estimated 6-fold increase in just the top 4 energy transition metals alone. And that represents a $13 trillion US dollar opportunity over the next 20 years. But we need to get moving. If we're gonna, it takes a long time to stand up new mines. So we really need to be making these discoveries much faster if we're going to have any chance of reaching net zero. So we need to be fast, we need to be scalable. And the other thing that we want to do is, as we transition to renewable energy, we don't also want to create a huge environmental catastrophe exploring for all these, the stuff we need. So how do we explore in a more responsible way, find widely enough to find new abundant deposits that have been overlooked, and satisfy that huge demand. So this is where we see Fleet helping, and this is exactly why we created ExoSphere.
Awesome, thank you. That was such a great intro, and it's so super exciting when people come into this industry from other industries. And I think, as you said, it requires out of the box thinking. As much as I hate to say it, as a geologist, we don't have a great success rate with finding deposits. So I love that you guys have combined that kind of thinking about satellites and remote exploration and come up with a really out of the box idea that's going to be quite a game changer for our industry, which is super exciting. And absolutely, as you said, we really do need those critical minerals. Like, we can't get to the future that we need without them. So it's just absolutely critical that we kind of get better at exploring and finding them. So I guess from that, we are trying to reach net zero by 2050. So how is ExoSphere going to help us achieve that?
Sure. So, like I said, the biggest thing I think is speed. We've got a lot of people with very big tenements to explore, some really ambitious goals. But when you're talking about exploring thousands of square kilometers in a single tenement, how do you speed that up? So one of the things that that we have gotten really good at Fleet, our core service is using small satellites to provide unlimited data. So low power connectivity, narrowband IoT satellite connectivity, and unlimited data. That's really new, because traditionally satellite, we all use it out in the field when we're exploring, but it's super expensive. And either you're going to spend huge money on a narrowband connection. Sending any data through is really hard, or you're going to have huge problems with power consumption. Like, you need to drag a generator out wherever you go, and that's really hard. So we've gotten good at using small satellites for low power narrowband IoT, but then because of the way we're able to manufacture satellites at scale, we can provide unlimited data. So this was one of those problems where we brought unlimited data to the table and said, how will this change things in exploration if we add a little bit of, like, if that wasn't a bottleneck anymore, if you didn't have to worry so much about how much data you're going to send out of the field, what would you do? And then we combined that with, there's a great photo of Buzz Aldrin deploying a passive seismic sensor on the moon in 1969. And what's really cool about that is they measured a bunch of moonquakes, like 7 moonquakes. But when they reran the data through a machine learning algorithm in, I think, 2005, NASA realized that they could actually pick up thousands of microseismic events. So we started looking at, well, what happens if we would add a satellite modem to one of those devices? That seems like something that we could put on the moon and unlock exploration on the moon. And suddenly we're doing this on Earth as well. So we brought that back and said, we combined unlimited satellite data, low power, low environmental impact sensors, and cloud processing to create a lightning fast, highly scalable 3D exploration solution to pinpoint high value mineral deposits. So so this is all about unlocking exploration at a scale and a speed never before possible. There's nothing else like it. And so we're super proud to bring this to market. And I think we've got a little video that we can just run through what ExoSphere is. So if you guys can cue that up.
I love that video, making exploration super cool. It's really exciting. And I wanted to kind of, just emphasize, I think, something that you said before, Matt, around that, just like you really are unlocking a potential that we've not really seen before. And I think the way that you guys have taken away that bottleneck around unlimited data, like, can completely change your thinking about how you solve a problem. And yeah, for people on the call, I think it just really is quite a game changer in that space. So very, very cool to see. So I guess next would be, can you, I guess, explain a little bit more about how it actually works?
Yeah, perfect. Yeah, so this is it. This is why this hadn't happened before. Traditionally, ambient noise tomography and passive seismic has been very, very slow. So getting that data back is a challenge. It's still hard. So what we had to do was build a purpose-built seismic node. It's a geophone node, but built for passive seismic, ambient noise tomography, rather than built for active seismic. Everything else on the market is really focused on solving a different problem. So we wanted to build some hardware that was perfect for this. Then we connected that with our satellite fleet, and then we bring that back to the cloud. And there's cloud processing to develop an image. So ExoSphere is an end-to-end service. It includes all of that as a package. You get we call them geodes, the seismic nodes, the satellite connectivity, the cloud processing. So you really don't have to worry about any of the moving parts or anything. We just deliver at the end. The end result is raw data and a three-dimensional point cloud. So we can plug that into your existing models, and we can map subsurface velocities in the survey area. And this lets you see deposits in 3 dimensions. So then, you're going to be plugging that into your existing data sets to help prioritize where you should be drilling. You can see, very often, if you're looking at a gravity survey, it's difficult to see, well, how deep below the surface is that, what shape is it, all that kind of stuff. So if you could suddenly see that 3-dimensional shape, it gets really exciting fast. So this is a process that, the technique's been around for quite a long time in volcanology and just more kind of pure science. And I think gaining traction in the market in commercial mineral exploration. But it's just been very slow. It takes 6 months. I've heard of surveys results taking like 12 months with all the logistics and messing around. So with ExoSphere, we can bring this down to like 4 days, which is, a huge, I mean, it's a game changer, right? Like suddenly you can be doing, getting results in real time, telling the team out there in the field to move the array. And most of our customers are really talking about sweeping arrays of geophones over thousands of square kilometers per year. So it really means that you can be very targeted, very flexible. Like we said, it hasn't been possible before to do things like this.
Yeah, it's super exciting to think about how you can speed up your exploration workflow and just the sheer amount of data that you're going to actually be able to collect, but not just the amount of data, how you can actually tangibly see outcomes and use that in your exploration workflow as well. So Darren, keen to hear a little bit more from you about the technique specifically that you use to create those models, if that's okay.
Sure, Holly, yeah. As Matt mentioned, we use a technique called seismic ambient noise tomography, ANT. It's been around for many years. On a more broad scale, crustal surveys, imaging deeper crust on a continental scale. There's a lot of scholarly peer-reviewed articles out there describing, these type of ANT investigations. Recent advances in processing speeds and the science around ANT, it's allowed this method to be adopted into mineral exploration. So it's really quite new, and talking to people in the exploration industry, they haven't necessarily heard of it. Maybe they understand the concept, but never applied in mineral exploration. So at the heart of it, ambient seismic noise tomography is a method that can give you the subsurface image using background vibrations in the earth. And you would have seen in the video, natural phenomena, oceans and rivers, anthropogenic activity, cities, towns, highways, rail, wind. These all produce this ever-present ambient noise, this ambient hum of the earth. And that's the source that's recorded. It's an array recorded method. So we use multiple array of geodes, and they're laid out over a grid covering the area of interest. So, the scale, as I mentioned, has been from crustal down to much smaller scale. So for ExoSphere, the seismic noise recorded by an array focuses on that area, which can be local, like a few square kilometers with a few 100-meter spacing between the geodes, and then up to regional scale, as Matt mentioned, screening a tenement scale, looking for points of interest, structures on a larger scale that may indicate, there's a reason to focus in. The data's cross-correlated. The method allows you to cross-correlate the data between the geophones, producing what's called an impulse wave, sort of a pseudo-active seismic source, if you like. The processing of these many impulse waves across the geodes in an area is what generates that three-dimensional image of seismic velocity. So as Matt mentioned, it was really that change in the ability to process the data more rapidly that's allowed the traditional method, which takes months and months, down to a number of days. So I feel like that's probably what has limited uptake in mineral exploration, is that lag in the visualization. So fleets removed, automated many of those steps in the traditional survey. And, ExoSphere, like Matt said, has cut it down to days.
Exactly.
Yeah.
Yeah. And so like I was saying, the first big innovation was to remove the delay in accessing the data. Like, okay, we've got unlimited data, so let's get it out of the field as fast as possible. And to do that, there's no hardware that would work for this out in the market. So we had to create something new. This is now our third generation sensor. And it is amazing. I'm constantly amazed, actually, every time we throw satellite engineers at a hardware problem. It's awesome what comes back. So then that's connected to directly to low Earth orbit satellites, just over 500 Ks up. And we use low power frequencies, which means the geodes are battery operated. So they'll last for a bunch of surveys before they need to be recharged. And delivering that result in a few days means, okay, now either take a closer look or roll the array onto the next piece of the tenement that you're exploring. But you can do a few surveys before you need to recharge the geodes. So next we put the processing of the full arrays data in the cloud. So we bring it back via these satellites, and that's tied to our web portal Nebula. And the goal there was to automate and reduce the time it takes at every step. We didn't know when we started on this journey just how many things we could automate and how we could streamline, but it is amazing what happens when you take unlimited data to a problem. And suddenly you go, why is this taking so long? Why is this taking so long? Suddenly we remove bottleneck after bottleneck.
Yeah, and sometimes having unlimited data creates problems in itself, obviously. So I think, yeah, it's not to be underestimated the importance of that automation, the automation steps that you guys have taken. And I think that's where it really comes into difference for geologists and how quickly they can access that and how much they actually need to do. They don't need to kind of be interpreting that raw data. So yeah, I suppose, Darren, could you tell us a little bit more about that from, the side of how does the geologist actually use the data?
Yeah, sure, Holly. We've had a lot of chat with different geologists, and they tend to get excited when they see what can come down, what type of data they can get. I guess the key thing is that the easy ore deposits have been found, and like Matt said, if we're going to accelerate exploration, then we need to do it differently. And we've found the easy stuff. We need a different way to find these high value deposits and also critical minerals, in settings that are undercover. And that's really where the data is coming back to the geologists, the decision makers in the business. Comes back as a high resolution 3-dimensional seismic velocity model. One of the best things about the ExoSphere is that you're seeing through cover. So you're seeing down to depths, 1 to 2 kilometers with reasonably great resolution. And, you can see the thickness of cover, the depth of the basement, the topography of the basement. You can see into the basement and identify structures through variations in the seismic velocity. So you can see anywhere that seismic velocity is changing in the material. So you can see lithology, you can see alterations within the material, structure and faults, and you can interpret those in 3 dimensions. So you can infer orientation and trend of structures and faults within that material. So I guess seismic velocity, the way that ANT works is that the seismic velocity correlates really, really well to rock density. So essentially what we're giving our clients in real time is I guess a proxy for rock density. And again, we can see these type of, or image these type of changes in rock density. And what we know that the exploration geos can use it to produce targets. They can look at, they know the ore body, they know where mineralization is hosted. They know the kind of structures that they might be looking for. And if we can assist them in identifying areas of contrast in rock density associated with those structures, then that's what we can do. So ultimately, the best thing is that we can dramatically increase that exploration efficiency. And the speed. So there's less time exploring, and they can move more rapidly into production and extraction of a resource. And the type of increase in speed we're talking about is, traditionally, as Matt mentioned, 3 months, 6 months, down to days. So if you can move across a tenement, move across a number of different exploration leases in rapid time, up and down ranking potential targets, that's a real benefit. And that's what we hope that the people in the exploration teams are going to get from this.
Yeah, absolutely. Thanks for that. And I think, generally we do drastically underestimate, how much efficiency can actually help us, increase our success rates. I think we often just look back to technology, but the efficiency part is huge. And Matt, I wonder if you could, I guess, go into that a bit more and talk about, how important efficiency is in this process.
Yeah, I think the biggest thing from an investment standpoint, right, is looking at, like, you want to get results as fast as possible. We all do, obviously, and those results, being able to rank targets and indicate deposits, get to value estimates faster. All of that is going to be fantastic. So what geologists can really use this data for is to generate a highly targeted drill program. And it's a bit like having X-ray vision to see under the earth. So you're still going to be drilling, but drilling's super expensive, super complex. One of the things we know about exploring other planets is every time someone puts a drill on another planet, it fails. So it's we're like, let's do everything we can to avoid drilling until we absolutely have to, and we know what we're doing. You don't want to be drilling at random anymore. So it's drilling's expensive, complex. You don't always know what you're going to find. So with ExoSphere, you waste less time on that, and you can spend your drilling budget with a lot more clarity and surety around what you're actually going to be drilling into. So yeah, exploration efficiency is absolutely a critical metric for investors. And then we think a lot about we're working with the top big miners and then the junior explorers that are trying to just get to that discovery as fast as possible with limited budget. So naturally, given this pressure to deliver, this kind of innovation is absolutely critical to improving their performance. And the other cool thing is being more efficient financially with ExoSphere is also taking a more responsible path as well.
Yeah, absolutely. I think naturally, like you say, when you're more efficient, you tend to be having a lower impact as well. So yeah, can you talk a little bit more about what it means to explore responsibly?
Yeah, this is something that's very, very close to our hearts, is transforming the way exploration is done so that it is limited impact. And you saw images of those, of the geodes. These are things that can be hand carried into exploration areas. They can onto site. They're installed a few centimeters in the ground. So you're just using hand tools and little buggies to get around. So it's being able to do this before you go on a large scale drilling program or anything is absolutely awesome. So we can also do things like it's quite resilient. So if there's a sensitive object or area on a tenement, you can image around it and underneath it without disturbing it. So you don't have to place the grid absolutely precisely. It's super resilient that way as well. So yeah, just a small team in a four-wheel drive can be placing geodes and moving them around. And that's a very different way to do seismic than with vibro-sized trucks and active. This is not active seismic. People very often, when we start talking about seismic, they start saying, okay, where are my explosions? Where are my vibrating trucks? It's not that. It's all ambient noise. So yeah, I think this is the big thing is that's what we mean when we're talking about limited impact, is being more sensitive and still getting a fantastic result before you start drilling.
Yeah, absolutely. And you guys can really collect a huge amount of data over very large areas with basically no impact to that area at all, which is awesome. Yeah. So yeah, on that, Darren, I'm keen to hear from you a little bit more about, obviously we have a lot of different, particularly geophysical methods in our exploration toolkit. Can you talk about how ExoSphere kind of compares and complements other methods?
Yeah, absolutely, Holly. So in the discussions we've had, we're talking to people that have used a number of different geophysical tools and methods to investigate, targets. And where we see ExoSphere is another technique for consideration in that suite. But ANT will complement most other techniques because it's a method that can excel where other methods are a little bit weaker. When it comes to depth penetration, ambient noise tomography has fantastic depth penetration. It's got an ability, as Matt mentioned, you don't have to be directly above a target to image it. So it's not limited in terms of access. The other thing around ambient noise tomography is that, it can see through that first reflector where other seismic methods potentially can't, or it can see through a magnetically susceptible cover sequence that maybe, other methods can't. So it's going to add value when it's part of the suite of exploration tools. It's particularly complementary to gravity because of its ambient noise tomography is linked to seismic velocity or density. Gravity as well, you know, is linked directly with rock density. So, you know, they complement each other really well. So gravity, again, is very, very commonly available data set. Most exploration groups we've spoken to have abundant gravity data, and ambient noise tomography, you know, its key strength is overcoming the inherent issue of depth resolution with gravity. Do you have a big gravity anomaly at depth or a little one that's shallow? And that's where we can run ambient noise tomography across, and in real time with ExoSphere, start up and down ranking deposits based on the depth of the gravity anomaly. I mean, is it out of economical depth range? Is it as big as it really seemed? Or, you know, something that's innocuous maybe is the best target when you've reviewed it with ambient noise tomography. So again, it's really about speeding up that regional exploration, de-risking the drill program, up and down ranking targets, and providing value to the exploration team. You know, as I mentioned, there are other seismic techniques available to explorers, and each has its own, I guess, its use case. Matt mentioned active seismic is very expensive. It's challenging environmentally, high impact, and often, you know, getting access to land, approvals, things like that can be difficult and time consuming. So look, it is a widely used tool, and it does give deep, high resolution data sets, but there is a cost. Other passive, low impact techniques are limited by the scale or speed of the method as well. So for instance, HVSR provides a really inexpensive way to get a 2D survey of shallow bedrock interface, but, you know, again, is limited in its in that it's a single point measurement. It's going to be slow to get results. It's not in real time. So again, you know, it has a place within the toolbox. So I guess the key thing is that, you know, these other tools are going to be part of an exploration program, and that's great. But nothing's going to match the combined, I guess, speed, our ability to scale, our ability to redeploy and refocus imaging, and, you know, the low impact to the environment that we've developed with ExoSphere.
Awesome, thanks, Darren. I think definitely, yeah, active seismic's been an interesting space, and there's been lots of great success with that. But
Sure.
What I'm excited about this solution is that you're really opening it up to a lot more people, because it is so expensive. And I often hear from explorers like, oh, you know, we just can't afford to do that. So, you know, this really opens up more opportunities for the broader market as well, which is super exciting. And, you know, I think another thing, kind of looping back, that for me is super exciting as a geologist is just that ability to have that data coming through so quickly, and being able to, you know, Matt, as you said, we're all explorers. We're really excited about exploring, and like getting that new data through daily and building our understanding of the world around us is what does get us out of bed every morning. So yeah, super excited for the geos to be able to get their hands on this. But like, thanks guys for running through that in so much detail. We do have time now for a couple of questions, so I'll jump straight into those before we kind of close out. So the first one, I think, probably is for you, Darren. So this question is from One Shop, and it is, what is your standard line spacing, and how long would you leave your geode in place? Plus, are there any plans to use the geodes with an active source?
Yep. Thanks, Holly. So there's not a standard spacing. It's a case-by-case basis, really dependent on the target, the nature of the target, and, you know, the resolution that's needed or required. In terms of, I guess, taking active, it is something that the geophones, the geodes could potentially do in the future, but it would really be dependent on demand for that type of thing.
Awesome, thank you. And the next question is from Jordan Scott. What is the approximate detection area, both in breadth and depth of a sensor?
Yeah, so the geodes themselves on their own will give you no data at all. As I said, they cross-correlate between, I guess, each pair cross-correlates within the array. So it is an array-based method. And realistically, to get a usable, useful data set, you'd want at least 15 geophones deployed, and more likely up to about 40 as a starting point to really start to get useful imaging and that cross correlation and building the impulse waves for interpretation. So and then in terms of their depth penetration, essentially the array, there's a rule of thumb around the ultimate array spacing, the outer nodes, is about a 4-to-1 ratio. So to see down a kilometer, you want these ultimate margin of the array to be at 4 kilometers. And that's just a rule of thumb for imaging down at depth. And in terms of resolution, it's around about 10% above 500 meter depth. So if you've got a spacing of 200 meters, you're going to resolve around 20 meters. And then below 500 meters, really your resolution, your ability to resolve structure or seismic velocity differences, I guess, is going to be about 10% of depth below 500 meters. So there's a rules of thumb that we would look to work through with each on a case-by-case basis.
Awesome, thank you.
Yep.
Now, next question has come through from a few people, probably an unsurprising one for you guys. But the questions are around kind of what metal ores you can accurately detect, and if there's any kind of ore specific techniques. And then, I guess on a similar vein, like, do you specialize in any specific ore body types?
Yep. So no, it's not specific to any kind of ore body, I guess, or mineralization. So what we're looking at is, as I mentioned, that difference in seismic velocity. We have had a client we're talking with who's actually done seismic velocity testing on their core in the core shed to enhance their ability to interpret the survey more directly. So they're looking at ability to maybe isolate those areas of that specific material within the subsurface, right? So really hone in on detecting that rock of interest. So ultimately, it's really about that seismic velocity difference. So it's not targeted on any specific material. It works really well because of its depth penetration and ability to, define different rock densities. Works really well in IOCG, and we've had seen success there. And but really, again, if the explorer understands their ground, they know what their target looks like, we can define the best way to investigate that, to really enhance that size, understand the seismic velocity differences that we're looking for.
Awesome, thank you. So next question we've got is from Julian, although I think we've already answered this one. So this is around what sort of surface grid density and extent would be typical. So I think we've already covered that previously. So I'll skip to the next question around, will this solution be available in New Zealand? That's from Richard Cave.
Absolutely. Yeah, we're already working all over the world. So just, get in touch and we can look at what we can do. We're mainly just limited by, we're growing really fast as a team, but we've got limited spaces, I guess, and limited spaces on the network. So have those conversations with us now so we can figure out where we can slot you in. But yeah, all over the world.
Awesome, good to hear. It's available for everyone. That's great. And so that's probably all the time we have for questions. So before we wrap up, Matt, is there anything else that you'd like to add?
Yeah, I think just we're super excited about this. Obviously, it's a revolutionary service that we're producing here. That's changing the game, or the game is changed, you know, in mineral exploration. So over the next few decades, technologies like ExoSphere will help satisfy this incredible demand for critical minerals. So we're really mission focused on supporting that net zero target. And it's a big opportunity. I mean, it's like $13 trillion of discoveries that we need to make. I mean, that's the same size as the global oil industry. So, you know, this electrification of the economy is creating a huge boom. And this is how it's technologies like this that will enable us to really take advantage and get stuck in, find these things. So yeah, this is exactly what ExoSphere is going to be perfect for. Get in touch. We'd love to hear from you. And yeah, help you explore more widely and rapidly than ever before.
Thanks, Matt, and thanks, Darren, as well. And yeah, I couldn't agree more. It's super exciting, and we haven't seen something like a step changing in exploration for a long while. So I'm super excited to see this come out and see people starting to use it as well. So it's fantastic.
Absolutely.
So yeah, thank you for everyone on the call for joining us today to hear about ExoSphere, Fleet's new mineral exploration product. As Matt said, if you want to get in touch with the team, please do so. You can email directly at sales@fleet.space. And I think everyone on this call will get an email out about contact details as well. And of course, you can find out more on the website, fleetspace.com. So head there as well. And we will send out a survey to everyone at the end of this webinar as well. So we really appreciate your feedback on that. That'd be excellent. But yes, thank you again so much for joining us. And yeah, look forward to hearing about how you use ExoSphere. Thanks, everyone.
Thanks, Holly. Thanks, everyone.
Thank you. Thank you.